Hello and welcome to today's lesson on decimals and percentages greater than 100%. If you want to pop today's date and title in your book and then have a go at the do now question, which is on your screen. So the do now question wants to know which of the amounts is bigger, find the fractions of the amounts to help you, pause the video while you have a go and then resume playing when you want to check your work. So for 3/5 of 25 then, firstly work out what 1/5 of 25 is by working out 25 divided by 5. This will give you 5. Multiply this by 3 because you want 3/5. That will give you an answer of 15. For 2/3 of 18 then, if you work out 1/3 to begin with, so this is 18 divided by 3, which is 6. Multiply the result by 2 as you wanted 2/3. This gives you an answer of 12. So the bigger amount would have been the 3/5 of 25. To work out 4/7 of 49, firstly work out what 1/7 of 49 is. So 49 shared or divided by 7 to give you 7. Multiply this by 4 as you want 4/7 of 49 to give you 28. To work out 5/6 of 36, firstly work out what 1/6 is, so 36 divided by 6 to give you 6. Multiply this by 5 to work out 5/6, so this is an answer of 30. For 3/11 of 55, firstly work out what 1/11 is, so 55 divided by 11 to give you 5, and multiplying this result by 3 to give you 15. For 1/3 of 45, 45 divided by 3 to give you 15 as well. So for the second pair of results, the bigger answer was the 5/6 of 36. And for the last pair, a little bit of a trick question, they were both the same, so neither amount was bigger. If you had a go at question 2, Jack says that 45% of 340 is larger than 35% of 380. Decide if he is correct. Remember from previous lessons, to work out 45% of something, we do 0.45 multiplied by 340. Or you could change this to a fraction. You could work out 45 1/100ths of 340. So this gives you 153. For 35% of 380, this gives you 133. So yes, Jack was correct. So why are we learning about decimals and percentages greater than 100%? So our hook question for today. A house has a starting value of £70,000. In 5 years, its value increases to £105,000. By what percentage has it increased? Well, you'll notice that the price has increased by £35,000, which is 50% of the original amount, or half of the original amount. So its value has increased by 50%. If you do 70,000 multiplied by 1.5, this gives you the £105,000. So a multiplier of 1.5, which comes from the 100% being the original value, plus an increase of 50% is 150% of the value. And changing this to a decimal by dividing by 100 gives us 1.5. And this is where the decimals and percentages greater than 100% come in. So our success criteria today, as a recap then, for the bronze objective is converting fluently between fractions, decimals and percentages less than 100%, which we've done previously. The silver and gold objectives are exploring fractions, decimals and percentages that are greater than 100%. Have a go at the cold call question, which is on your screen if you pause the video and then resume playing when you want to mark your work. So what percentage of the square is shaded green? Well, in our 100 square, you'll notice that 3 columns of 10, 30 of the squares are shaded green. So this would be 30%. What is this as a decimal? Remember, to get from a percentage to a decimal, we divide by 100, and 30 divided by 100 will give us 0.3. Be careful, as this can be easily confused with 0.03. Now 0.03, if we multiply this by 100, this is actually 3%. If this was shaded in green, this would represent just 3 squares, not 30 on the grid. Again, what percentage of the square is shaded green this time? So this time 80 of the squares are shaded green, so hopefully you recognise this is 80%. What is this as a decimal? So 80 divided by 100 would give us 0.8. Why is it not 0.08? This would be because 0.08 represents 8% and not 80%. So 0.08 would just represent 8 squares shaded in the grid. What percentage of the square is shaded green this time? Well, this time 35 are shaded in, so this would be 35%. What is this as a decimal? Well, 35 divided by 100, sorry, going back, would give us 0.35. Let's have a look now at this one. So what percentage is shown by this diagram? So this time you'll notice we have two 100 squares. The first one is completely shaded in, so this is 100%. And of the second grid, we have 43 of the squares shaded in, so this is 43% of the second grid. So in total, 143% is shaded in, so this is more than the one whole grid. So as a decimal multiplier, again, to get from a percentage to a decimal, we divide by 100, so this gives me a multiplier of 1.43. Some standard examples then, the standard examples being the examples that are decimals and percentages less than 100%. Pause the video while you have a go. So what percentages are shown by the following diagrams, and write the decimal equivalents too. So for the first one, hopefully you noticed that 46 of the squares are shaded in blue, so this is 46%. The decimal equivalent would be from 46 divided by 100, which is 0.46. For the second diagram, it's easier, as these are place value counters, to get the decimal equivalent first. So we have 3 place value counters of 0.1, so this is 0. or 0.3 altogether. Then we've got 0.01 and 3 lots of, so in total this is 0.03. So altogether the decimal equivalent here is 0.33. To get the percentage equivalent, we multiply this by 100 to give us 33%. Here we have a bar going from 0 to 1 with 10 equal spaces. So the bar shaded represents as a decimal 0.8. The percentage equivalent, multiplying this by 100, would give us 80%. So I've classed these now as non-standard examples, as these are decimals and percentages greater than 100%. So on this one, have a go at the percentage and the decimal represented by the blue or lilac shading. So to start with then, the full 100 grid is shaded in, so this is 100% of the square. For the second one, you'll notice that 66 are shaded blue, so this is 66%. So in total then, with our diagrams, this represents 166%. If we divide this by 100, we get a decimal equivalent of 1.66. Another non-standard example, so here this is a bar. So the bar is completely filled in from 0 to 1, representing 100%. And we have 2 extra filled in, so this would represent 20%. So in total, this represents a percentage of 120%, dividing by 100 gives us a decimal equivalent of 1.2. Pause the video now while you have a go at this question. So it asks you to match the equivalent decimals and percentages. Write the equivalent percentage and decimal for any cards that are not paired up. So hopefully these are the ones you matched together. So 0.08, if you multiply this by 100, it gives you 8% as a percentage equivalent. 0.80 is the same as 0.8. It's just that the 0 here is not really needed because it's not holding the place value with the 8. It can hold itself here. So these are equivalent to each other. If we multiply by 100, this is the same as 80%. 18%, if we divide 18 by 100, we get a decimal equivalent of 0.18. For 1.8, to get the percentage equivalent, we multiply by 100, which gives us 180%. For 0.8%, to get the decimal equivalent, we need to divide by 100, which gives us 0.008. Pause the screen now while you have a go at filling in these blanks. It might be an idea to jot these down on notepaper or have a go in your exercise book. So 99%, remember to get from a percentage to a decimal, we're dividing by 100. So 99 divided by 100 is 0.99. To go backwards then, to go from the decimal back to the percentage, we need to multiply by 100. So this is 101%. Here we're going from a decimal to a percentage, so multiplying by 100 would give us 90%. Going from a percentage back to a decimal, we are going to divide by 100, so this gives us 1.1. Now on to the true or false questions, so pause the video while you have a think about each one. So 50% is equivalent to 0.5 as a decimal multiplier. Yes, it is, because 50 divided by 100 is 0.5. 75% is equivalent to 0.75 as a decimal multiplier. Well, yes, it is, because 75 divided by 100 is 0.75. 115% is equivalent to 0.15 as a decimal multiplier. Well, no, that's false, because 115 divided by 100 is 1.15. Remember, 150% is greater than 100%, so the decimal equivalent will mean this is greater than 1. 125% is equivalent to 1.25 as a decimal multiplier. Well, yes, this is true. 125 divided by 100 is 1.25. To convert from a percentage to a decimal, we just multiply by 100. Well, of course, this is false. To get from a percentage back to a decimal, we need to divide by 100. 20% is equivalent to 0.02 as a decimal multiplier. No, this is false, because 20 divided by 100 is 0.2, not 0.02. 109% is equivalent to 1.9 as a decimal multiplier. Well, no, this is false, because 109 divided by 100 is 1.09, not 1.9. 1.9 is 190%. 70% is equivalent to 0.7 as a decimal multiplier. Well, yes, that's true. 70 divided by 100 is 0.7. So now you might want to have a go at the worksheet from this lesson. So that is within the folder of work that is on the website, and the answers are there as well. Once you've done that, you might want to have a look at these questions. So is this correct? So Tom completes the following for his homework. How many mistakes has he made? Pause the video while you have a look. So going through these then, to get from a percentage to a decimal, we are dividing by 100. So 50 divided by 100 certainly will give us 0.5. 67 divided by 100 is correct to give us 0.67. 32 divided by 100, this is also correct to give us 0.32. 7 divided by 100, hopefully you spotted this as incorrect, as 7 divided by 100 is 0.07, not 0.7. So 0.7 would represent 70%. 102 divided by 100 is 1.02, so this is also incorrect. 1.2 would represent 120%. 138 divided by 100 is 1.38. This is greater than 100%, so should be a number greater than 1. 0.38 represents 38%. 250 divided by 100 is 2.5, so this is also incorrect. 2.05 would represent 205%. Chris says that he has increased his test score by 100%. Is this possible? Well, yes, this is possible as long as Chris had scored less than 50% to start with. So if his test was out of 100 and he scored 30, then yes, he would be able to increase his test score by 100%. So this would be doubling the amount. He would then be able to get 60. If to start with he had got more than 50% to start with, then he wouldn't be able to increase. So for example, if he got 60 out of 100, to increase his score by 100% would mean he'd got 120 out of 100, which in this instance is incorrect. So where would we use this? So we had a look in the hook question at house prices increasing. Let's have a look here. So a factory produces 50 bars of soap per hour. It purchases a new machine and production increases by 20%. How would we calculate the new amount produced? Well, the 50 bars of soap is 100% of the amount they are already producing. If they increase this amount by 20%, they are working at 120% of the amount, and this is a multiplier of 1.2. So working out 50 multiplied by 1.2 would work out that the new amount produced is 60 bars. You could also do this just by working out 20% of the 50 bars, which is 10, and then increasing that 50 by 10 to give you the 60. So have we fulfilled the success criteria? Hopefully we have. So the bronze objective, hopefully you are competent to write all the percentages that have appeared on your screen as decimals by dividing by 100. For the silver and gold objectives, that's writing fractions, decimals and percentages greater than 100%. So looking at 105% and 137%, hopefully you now know how to write these as decimals by dividing by 100. And the last question for you to think about, is it possible for a car to decrease in value by 150%? Well, hopefully you can see that it isn't. If a car decreased in value by 100%, that would be meaning that its value was now 0, so it wouldn't be able to decrease by anything bigger than 100%. Now go and have a go at the worksheet. Also, make sure that you follow the Hegarty tasks that have been assigned to you this week as well. Thank you for watching.